Hello everyone, I am Professor Amit Vyas, Computer IT Department from Dr. Subhash Technical Campus. Today, we are discuss about the topic of algorithm and the topic we are prepared, the graph. So what is the graph and the types of graph and what is the some order of graph and how can you represent the graph and tree. So further discuss, we can show about what is the graph. So this is the one graph you can show that here. Number of nodes which are connected to each other based on the edges. So edges which are connected number of nodes. So here we can show that A, B, C, all the number. It is called node or vertices. And this is the edges between A and C. So this is the represent of the graph. Now, graph is a one data structure is consistent of number of node or number of edges, the number of edges which are linked between number of two nodes. So this is the represent of the graph. Then next we can show about what is the vertex. Each node of the graph it is represent as a vertex. You can show that. Here vertex it is denoted by the V equal to A, B, C, D, E and F. You can show that this is the all the vertices. And what is the edges? The edge is represent the path between two vertices or two lines between two vertical lines or vertices. The edges is represent the path between two vertices. So you have saw that here. What is the edge? AB is a one edge because of it is connected one edge. AC, then BE, BD and all the connection, DF, EF, all the connection it is denoted by the edges of the E. So this is the graph information. Now what is the types of graph and further information? Then one is a null graph. A null graph is graph. It is defined as a graph which is consistent only of isolated vertices. It means each and every graph have some value for denoted by the null value. For example, this is one point, but it is not connected to any nodes or any vertices. So this is the graph or this is the denoted by the null graph. It means no vertices which are connected to anyone. This is the one single point. It is denoted. It is called the null graph. So what is the directed graph? In directed graph, a directed graph is a simple if there is the most of one edge from one vertex to another. It means mostly one edge and it is connected to another vertex. You can show that here. This is one vertex and it is the denoted particular direction. You have shown that here. The direction is denoted A to B. So this is the call of the directed graph. The represent of the graph in the particular some direction of the number of vertices. Next, undirected graph. You have saw that here. Number of graph or number of vertices which are connected to more number of element or nodes, but you have no direction, but only for the connection. So in undirected graph, each edges have a two element or subset of V. A simple undirected graph, it contains no duplicate edges and no loop. You have saw that here, no loop. And a graph which more than one edges between the same two vertices, it is called the multigraph. So it is also called the multigraph, and most of the graph means simple and undirected. So in the terms of the what is the undirected graph? In the undirected graph, the number of nodes which are connected to number of nodes, but you have no direction and the no loop it constraint. So it is called the undirected graph. So this is the diagrams. You have saw that the difference. This is the directed graph because of it provides some direction represent of the node or vertices. Here the node represent of the vertices for the particular direction. This is the acyclic graph and cyclic graph. You have saw that. So we can show that in the cyclic graph and acyclic graph. In the acyclic graph, the number of nodes, you have saw that this is one node A, B and C. This is represents a graph base, but here A to B connected, B to C connected, but C to A is not connected, but A to C connected. So you have saw that here one cycle is not created. So what is the cycle in the graph? Here if the node which connected A to B, B to C and C to A, it is one cycle. So here A to B connected and B to C connected, but here C to A is not connected. So this is the graph, it is called the acyclic graph. And here A to B connected, B to C connected and C to A connected. So here we can show that this is called the cyclic graph. So now this is the main difference. So next we can show the self loop. So what is the self loop? The big edge is the edge that is from the node itself. It is called the self loop. So this is also the self loop. You have saw that the represent of the self loop. Here the one node and it is represent itself. It is called the self loop. Here it is represents a direction self, but not self loop. It is called the self loop. Then next we can show the, so here we can show the weighted graph. In the weighted graph, we have two types. You have saw that here, undirected graph and the directed graph. So here the weighted graph, here some value is given, some two particular nodes or vertices. Suppose A and B is two nodes, then this distance is covered particular 2 minutes or 2 seconds for any weight. So this is one particular time or weight is given for A to B. Same for A to C and B to C and all the connection, it is provide some weight. So here it is called the undirected graph because of no direction is created. It is not you have go to the A to B and weight is 2 times or not represent particular direction. So it is called the undirected graph. In the graph, it is denoted some weight but not represent particular direction. It is called the undirected graph. And the directed graph, in graph, number of nodes which are connected to each other and provide some weight and also represent particular some direction, it is called the weighted graph. You have saw that here A to B, it is possible you have go to, but B to A is not possible. B to D is connected for particular some direction and also occupy some weight. So this is called the directed graph. Then next we have saw that sparse graph. The graph is J is denoted V and E. It is called the sparse graph if the constant is very few edges in the graph. For example, you have saw that this is one edges and it is represent big omega of V. In the graph, number of edges are near to the minimal number of edges, and the sparse graph is efficiently represented using linked list. So you have saw that here. This is my edges which are connected, and This is also the edges of connected, but here the connection is also provide some linked list base, or also connection is linked list. So this is called the sparse graph. You have shown the dense graph. So what is the dense graph? The dense graph is number of edges are maximum possible edges. So dense graph is, it means it is represent the maximum number of possible edges, and it is denoted big omega of v square. Dense graph is best describe the adjustment matrix represent. So what is the dense graph you have written? This is one graph you have shown that, and what is the possibility? The maximum possibility of edges. You have shown that in the only for one part you have shown that this part it is connected. The number of edges which are connection, because you have shown that this is the edge it is connect here, so here it is connected, so here it is connection. So maximum number of possible edges which are connected, and it is a represent of the dense graph. Then tree. T equal to V dash and E dash and subset of graph of V of E. So this is one tree. You have saw that tree is does not contain any cycle. So this is the importance. Tree does not contain any cycle. Tree is not, it occupies some cycle. It means you have saw that this is the one cycle A, B, B, C and C, A. So cycle is not connected in tree, while graph or subgraph is many constraint. You have saw that if the vertex V1 it is connected V2 and V4. So this is also one connection you have represent. Then V1 is connected V2, V4, V5, and if you are remove that, so this is also you have represent. So now tree is main constraint, it is does not contain any cycle, so tree is not possible create one cycle. Now this is the represent of the binary data structure. So what is the binary tree? A tree all the element have most of two child, it is called the binary tree. Each element in the binary tree can be have only two child. We typically the name of the left and the right child. You have saw that here. Mostly the number of nodes which are connected to each other, but this is one parent node you have saw that, and here two child minimum you have saw that one is left child and three is a right child, and also two have a two subparts or two child, it is 4 and 5, also here 3, here 6 and 7. So these types of structure which is represent the binary tree. Then binary tree, it is called the topmost node, it is called the root node. Here the 1 is a root node. Also if the 5, then 6, 7 and 8 it is the child node, and 5 it is the root node up to 6. Here 2 also be root node compared to 5, but in the structure of the binary tree the first element it is called the root node. Then represent of the graph. So the graph it is represent adjacency list representation, adjacency matrix representation. So the representation of the graph is, first of all we can show that undirected representation of the list representation and undirected matrix representation. So here you have shown that here number of one graph here denoted, and the number of nodes a 1, 2, 3, 4, 5 which are connected to each other some edges, but not represent some particular direction, so it is called the undirected. Now it is represent of the list. So first, how can you represent the list? You have saw that here number of nodes you have right here. The nodes you have 1 2 3 4 and 5, and now which is connected, and it is represent of the undirected. So now 1 is connected 2 and 5, so you have represent 2 and 5 here based on the list. It means you have represent the linked list. Now second, 2 which are connected 1 also 3 4 and 5, so you have saw that here 1 5 3 4 for the undirected graph. Now 3 which is represent and connected 2 and 4, so you have saw that 2 and 4. Now 4 which is connected 5 2 and 3, so you have saw that 2 5 and 3. Then 5 which is connected 1 4 and 2, so you have saw that 4 1 and 2, which is represent of the particular graph in the undirected for the list representation. Now we have represent the matrix. How can you represent the matrix? Here not every nodes or not every edge is it is denoted for the self loop. It means you have saw that this is called the self loop. Here we can show this is the self loop. So the in the matrix in the undirected, so it means you have not connected particular direction but only for the connection. So we have represent if the two nodes which are connected, we have put the 1 for particular matrix. Here 5 value you have saw that 5 nodes 1 2 3 4 and 5, so we represent the 5 cross 5 matrix. Now in the diagonal matrix or self loop is not connected, so we have represent 0 first of all. Then after 1 is connected, you have saw that here this is the 1 is connected 2 and 5, so we have put this position of the number. You have saw that 1 is connected 2, so you have put 1 and 5 1. Then 2 which is connected 5 4 3 and 1, we have put 1. You have saw that 2 which is 1, this is always 0 because of no self loop, and 1 1 1. Same 3 which is connected 2 4, so you have saw that here 2 and 4 we have put 1. Same 4 we have put 1 for 3 and 5, you have saw that 3 and 5, and then 5 which are we have put the value. So this is the represent of the undirected list of matrix representation. Next we have saw that the representation of the graph of the directed. So in the direction we have saw that here in the 1 which are connected 1 is connected 2 and the 1 is connected 4, so we have saw that it is put the 2 here, it is put the 4. Then 2 which are connected 5, so we have put 5. 3 which are connected 6 and 5, so we have put 6 and 5. Then 4 we have connected 2, you have saw that here this is the direction is occupied for the directed graph. Here no direction is occupied, so this is the importance. 4 which are connected 2, so now we have put 4 to 2, and 5 which are connected 4, so we have put 4. So this is the list representation. 6 is not connected to anyone, it is represent itself, so if you have not represent here, if you represent and it is not connection, so you have denoted by the 0. So now in the self loop you have saw that, so in the directed graph in the matrix you have saw that, and represent 1 2 3 4 5 6 and 1 2 3 4 5 6 because of the 6. Now If the connection is occupied, you have put the 1, otherwise we have put 0. 1 is connected 4 and 2, so you have put 1 here. 2 and 4 you have put 1. Then 2 which are connected 5, so you have 2. This is connected 5, you have put 1. 3 which are connected 5 and 6. 3 are is connected 5 and 6, so you have put 1 here. 4 which are connected 2, so you have put 4 to 2 1. 5 which are connected 4, so you have in the 4 you have put 1. 6 which are connected itself, so you have put just 1 here, not here. So this is one printing mistake, so you have check that and update it. So this is the represent of the matrix. Now what is the advantages of the graph? It is simple to represent, mostly easy to implement, number of edges is computed, and additional of the edges is done by some consistent of the time. So in the graph mostly you have represent based on the particular useful particular algorithm. So this is the importance of the graph, and number of edges you have easy to count and calculate that. Now what is the disadvantage? It required the more memory for represent of the graph. You have saw that if the undirected graph and the directed graph, the memory space is different. You have saw that if the 1 is connected to 5, so you have put here 1 and 1. So this is the memory is occupied. Here you have saw that 1 is connected 4 and 2, so this is the occupied. But the direction is different for particular space is occupied, and without direction, suppose here this is the undirected graph also, so the space utilization mostly are same. But in the directed graph, the space utilization of the compared to undirected graph is in the direction graph the low space utilization, but in the undirected graph is more memory is utilized. So this is the main conceptual difference. So here you have saw that require the more memory representation of the graph and take a huge amount of effort to add and remove the vertex. You have not removed the directly for a particular vertex. You have calculate that and manipulate of the particular size, and you have count which is the direction, and you have mentioned that. So this is the main importance of huge amount of time is taken for particular vertexes. It is need to some area of the size is n cross n, it is denoted. So this is the main disadvantage. One is the memory represent, it is a huge amount of effort and also large number of memory is used. Now the application of the graph. So what is the main application? The web crawling, social networking, network broadcasting of the routing. You have saw that in the social networking or the graph, you have connected a number of router to each other. So you have connected one is a one parent node or one is a root node, and number of node is spread particular sometimes you have occupy some distance, and now this is the connection is denoted. It means one is a binary structure, you have saw that here. One is main node and then another two graph which are connected, and then it is connection is mostly important for the network topology. Also the garbage collection, model checking, and solve the puzzles and game. You have saw that you have create some games, particular Ludo or any other. Then graph is importance for the particular network. So this is the application of the graph, and many more application of the graph you have saw that. Now we have referred the particular quick what is the graph and what is the importance. We have saw that graph in the graph this is it is represent some node, and it is the represent of the edges, the two node which are connected some edges. So it is a graph, and edges it is represent A to B, B to C, or sorry B to D, and all the represent of the edges. Now null graph we can show that only for one points, but the point which are not connect to anyone, it is called the null graph. Directed graph and undirected graph, you have saw that in the directed graph this represent particular some direction, and undirected graph it is not represent some direction. Cyclic and acyclic graph, in the cyclic graph it is occupy some cycle. You have saw that A to B, B to C, and C to A is connected one cycle and create one cycle. In the acyclic graph, it does not create any cycle. So this is the cyclic and acyclic graph. This is the represent of the self loop. You have saw that A is represent itself. It is called the self loop. Weighted graph and unweighted graph for particular directed and undirected. So you have saw that A to B and B to D is occupy some weight, and the weight it is called the weighted graph, but it is not represent particular direction. So it is called the undirected weighted graph, and it is represent for directed weighted graph because of you have go to the E to D, and it is the maximum time is 2 minutes or 2 seconds or any weight, but you have not go to the D to E nodes. Next we can show the dense graph, and now this is the tree is important. What is the tree? Tree is does not create any cycle, and the graph or subgraph is many constraint of. So you have remove some tree constraint or tree structure. It is also be connected. Suppose you have removed here V1, then V2 and V4 also be connected. Also you have removed V4 to V3, then V3 to V6, then it is also be connected. So this is the some subtree you have saw that. Then next, what is the binary tree? In the binary tree, we can show that this is one root node, and it is a root node is occupy some two parent, and it is the parent is most of two child node, and this is the root node, and it is a mostly child node. So this is the represent of the binary tree. Then this is the topmost node, it is called the root node. Then we can show that the represent of the list and matrix. So in the list we can show that one graph which are connected for the undirected graph and directed graph, but we have put some value. You have saw that 1 to 2 and 1 to 5, and we have represent 2 and 5 for based on the linked list. Also in the matrix, based on the node, we have created one table for matrix base, and we have put the value for the 1 because of here no weight connected. So 1 to 2 and 1 to 5 we have put 1 here. You also that 1 to 2 and 1 to 5 I have put 1. So this is the represent the undirected list and matrix. Also we have saw that the adjustment list represent of the directed graph. So in the same we have saw that 1 to 2 and 1 to 4 it is represent particular direction, so we have connected. And the same in the matrix we have put the value of 1. Here 6 it connect itself, so we have put here 1, not here. So this is the importance. So one minor changes. So we can show that the advantages of the graph. Disadvantages because of the it is required the more memory for the particular space in the graph. Now we can show the application for the network broadcasting and routing, solve the puzzle and games. So this is the many more importance of the graph and all the application. So thank you all of you.